So in the previous session, we looked at molar mass, and we also looked at how molar mass relates to formula mass and how to use the idea of molar mass in calculations involving substances. So we solved a couple of simple problems. Let's solve a few more problems using the idea of molar mass, that molar mass is the mass of 1 mole of a substance. So sorry, let me, yes. So in this problem, we need to calculate the number of formula units of a compound magnesium carbonate given in a certain number of pounds of that substance. So again, a few points before we actually solve this problem. Number one, what is magnesium carbonate? You have to have the correct chemical formula for this substance before you can start. So please go back to the previous sessions if you're having difficulty coming up with the chemical formulas. That information you have to have. Okay, so magnesium carbonate is chemical formula is MgCO3 because magnesium is in group 2A and carbonate is CO3 with a 2- charge. The other point that I would also like for you to recognize that the mass of the compound is given in pounds, but molar mass is always in grams per mole. In other words, in some stage of our problem setup, we will have to look into converting pounds to grams. Okay. The third point that I want to also I would like for you to think about is they're not asking us to calculate moles of the compound. They're instead asking us to calculate formula units of the compound. So now this is a problem that is not a one-step problem. This is a problem that is asking us to go from mass of a compound to formula units of a compound. So far, we have looked at two equations as related to calculations in chemistry, and one of those equations says 1 mole of a compound has Avogadro's number of particles, and the other equation says 1 mole of a compound has a mass equal to the molar mass in grams of that substance. So as you notice that at one end we've got the mass, that's what we are given, and they're asking us to calculate particles. So both of those are part of different equations. So this is not a one-step problem. This will have to be solved in a couple of steps going through moles. In other words, mass can be converted to moles using the molar mass equation, and then moles will be converted to formula units given the Avogadro's equation. Okay, so with this in mind, first step of course is go ahead and calculate the molar mass of magnesium carbonate. So 1 mole of magnesium carbonate has a mass of 84.32 grams of magnesium carbonate. Okay, now we are ready to set it up. Using the information given, we need to convert 1.12 pounds of magnesium carbonate into, first step, since this is pounds, we have to convert pounds to grams, so that pounds crosses out. Now grams of magnesium carbonate is what we have at this stage. So grams of magnesium carbonate will have to be converted to moles of magnesium carbonate. And then moles of magnesium carbonate will have to be converted to formula units of magnesium carbonate using the Avogadro's equation. Moles crosses out. So now when you fill in the numbers, you have 1 pound equal to 453.6 grams. 1 mole of magnesium carbonate equals 84.32 grams as you calculated, and then 1 mole of any and every substance contains Avogadro's number of particles of that substance. In other words, in this case, that would be the formula units of magnesium carbonate. Okay, so now we can go ahead and calculate using our calculator, and hopefully your answer comes out to be 37 6.282835674 times 10 raised to 23 formula units of magnesium carbonate. Now this answer is neither in the correct scientific notation nor in correct number of significant figures. So we need to account for both. We need to give the answer in 3 significant figures and also in correct scientific notation. So when you do that, the final answer becomes 3.63 times 10 raised to 24 formula units of magnesium carbonate. Okay, let's read this problem. Please go ahead and pause the recording. It would be a good idea to do so while you read the problem, assess the problem, try to create a strategy for yourself before we solve it together. Okay, so in this question, we are given the number of molecules of carbon dioxide. What is the chemical formula for carbon dioxide? CO2. They're asking us to calculate, however, the volume of carbon dioxide. Whoa, that is new, right? We haven't done that yet. But look at what they've given us besides the data. They've also given us the density of carbon dioxide. So let's stretch our thinking a little bit, try to connect all of these pieces into something that makes sense. We know we have molecules, we have particles of carbon dioxide, molecules because it's a non-acidic molecular compound. Molecules can be converted into moles of carbon dioxide using Avogadro's number. Moles of carbon dioxide can be converted into grams of carbon dioxide using molar mass of carbon dioxide. Is there something that relates grams to volume? Exactly, density. And density is given. So if we know the density, mass can be converted into volume. So in this question, we will be using density as an equivalence factor. But do note, it is the data that is given to us in the problem. Okay, so let's start solving this. Before you do that, it may be a good idea for you to figure out what is the mass of 1 mole of CO2. It is 44.01 grams. Okay. So we are going to start with the number that needs to be converted, which is not the density, it is the molecules that needs to be converted into volume. Now, so let's start with that, molecules of CO2. So first step, molecules will be converted to moles of CO2. Molecules cross out. Moles of CO2 can be converted into grams of CO2. Now, hold on for a second, because here's something else that you need to consider. At this stage, you would have the mass of CO2 in grams, but look at the mass unit given in density. It is kilograms. So yes, you would have to account for that. You would have to convert one to match the other. Otherwise, you cannot cancel them. So it may not be a bad idea to convert this grams into kilograms of CO2 so that you can take care of that. Okay. Then you can use the density given to convert kilograms of CO2 into liters, because it's the density is given in kilograms per liter. And then once you have liters, notice that the question is very specifically asking you to calculate the volume in milliliters. So you would have to do one final conversion of liters to mLs, so that your final answer is then in mLs of CO2. Okay, now let's put in the numbers. From the Avogadro's equation, we know 1 mole of CO2 will have 6.022 times 10 raised to 23 molecules. From the molar mass of CO2, we know 1 mole of CO2 equals 44.01 grams. We also know that 1 kilogram equals 1,000 grams. We know from density that, excuse me, we know from density that 1.1, what's going on here? 1.50 kilograms of CO2 is 1 liter of CO2, and then we know 1 ml equals 10 raised to minus 3 liters. Okay, once you've plugged in all the numbers into the calculator correctly, now please, a word of caution, use parentheses, because if you do not use parentheses appropriately in your calculator, your answer will not work out quite the way it should. Okay, when you have entered these numbers, the calculator gives us the answer as 3.4104498,529 mLs of CO2. It should be in 3 significant figures because both the molecules and the density is given in 3 significant figures. So when we round it, our final answer is 3.41 mLs of CO2. Okay, once again, go ahead and pause the recording while you read and assess this problem. Coming back, the simple way to solve this problem is to remember the units that molar mass is given in. Molar mass is given in units of grams for 1 mole. In other words, grams per mole. Now, what is on the numerator? Mass. What's in the denominator? Moles. Do we in this problem know the mass of the sample of acetaminophen? Yes, we do. We know there is 30.24 grams of acetaminophen in this sample. Do we know the moles of this sample? Yes, we know that the sample is 0.200 moles of acetaminophen. Now notice when you do that, the answer has units of grams per mole. Those are the units of molar mass. So if you divide these numbers, you get 151.2 grams per mole. You do have to round for significant figures. Now numerator is in 4 while the denominator is in 3. So the answer needs to be in 3 significant figures, and hence 151 grams per mole will be the molar mass for acetaminophen. Okay, so for a very quick review, we can convert moles of a substance to mass of a substance using molar mass of that substance calculated in grams per mole. In other words, so many grams in 1 mole of the sample. We also looked at a couple of problems which converted between mass of a substance and volume of a substance because density relates these two properties to each other. So quick conversion, basically you can relate these units to each other using an appropriate conversion factor.